Welcome to the DZ Easy Show, where we create the decentralized Betterverse using DZs.
So Ted, I want to first thank you for communicating your ideas very thoroughly, that we can dig deep into them and take them forward and teach them to people. My question is it possible to prioritize your innovations in terms of what we should work on first, bring forward, or you need them all at once?
I have no idea because
Yeah.
I don't know what to do. Please go to xanadu.com/demo and play with that.
Yeah, I do have an exhibit with your demos running, so if anybody wants to come and see it. Yep.
Welcome to the DZs Show, Episode 3. In this show, we're going to explore the initial GitHub repository for DZs. But first, I want to show you some things in the Hypercore protocol in the guides. So what we looked at previously is the Hypercore CLI. And here you can see the commands grouped by the structures they operate on. We were looking at the hyperdrive commands for cataloging, to see a file, to put a file, to do diffs between directories and ls. But what we're going to explore further is, let's go back. So this using hyperspace will help you get started with the daemon and how to programmatically create the server and client and connect and access the hyperdrive programmatically. Okay, but what I want to show you is the standalone modules. So here is Hyperswarm is the distributed hash table, and Core Store for managing hypercores. So this is another way of getting started programmatically. But Hyperdrive is what I'm building upon for DZs. And these features are important. Sparse downloading. Readers only downloaded the portions of the files they need. Fast lookups. It's a distributed trie structure. Version controlling by default. And you can even do version tagging now. Okay, so this walkthrough gives you some examples of how to create a hyperdrive and to, when it's ready, to get information from it. And you could use random access memory for testing and connecting it to hyperspace to get it hosted. Okay, and then how to read and write files in a hyperdrive. There's promises. So this is the technical details to get it to work. But what I want to show is this GitHub for hyperdrive to show you all the possibilities. So it's a secure real-time distributed file system for P2P file sharing. We talked about version control, composable. This is going to be very important using a mount system. You can nest hyperdrives within other hyperdrives. So the way I envision using this in DZs is, say Alice starts creating a hyperdrive and puts files in it, and Bob wants to mount Alice's hyperdrive within his own hyperdrive. Well, the mount command would allow this, and if we're talking about Tumblr addressing, so say Alice is 1.1 and Bob is 2.2, well, Bob could create a 2.2.1.1 and nest Alice's work within his, and then he could comment on it and share things back with Alice. So that's where I see the power. And they're shareable by a 32-byte key. Sparse downloading, which is very important, because say you have audio and video in it, it is possible to stream through the files, and then you could have the power of a peer-to-peer network doing something like a BitTorrent, if everybody's watching the same video, for an example. Okay, yeah, the lookups are in a distributed trie structure, which is just magical. Version tagging. Okay, so yeah, this goes through all the same things. So there's examples here about the API fully documented, and I'm going to look for mount. Gets mount information about an entry. So you have metadata for the mount point, the absolute path of the parent mount, and the mount's metadata record. Okay, so here's the documentation about hyperdrive mounting. Okay, so you could mount other hyperdrives at paths within a parent drive. Okay, composing larger collections out of other shareable units, aggregating content from many users. You could have group mounts. Okay, so it's drive.mount, a name, a key, and options. So let's see, the options are a version of a drive to check out. So like Bob could comment on version 2 of Alice's work, and then Alice could go on and create a version 3, 4, 5, and later Bob can mount version 5. So you have full provenance. And let's see, mount stream. So this is important stuff for anybody working on this to learn how to do this. So currently all the DZES ideas are in erangel/articles. Okay, so you could click this to go to read this article, and you could click this to read this article, and then the example goes into the test cases directory, and it does an annotated directory listing of the files and my thinking of how they would be used to create decentralized ZZ structures. Okay, so let's walk through this article a little bit. So we can't call it zigzag because Ted Nelson has a trademark on that, so we're calling it DZES. To learn more about Ted Nelson's zigzag ideas, this is his page. Okay, so Ted defined a ZZ space, an arbitrary space of cells connectable arbitrarily plus to minus in a plurality of dimensions. I love these concise definitions. And we're building ZZ structures on ZZ space, and you could have a ZZ engine. For example, GZZ has operations upon ZZ structure and views. Okay, and I recommend reading more about Ted's cosmology for his high-level ideas. And then, what is DZES? Okay, I want to be an open source conceptual data structure that represents graph data structures using whatever technologies are available on a decentralized web. So what's important is ZZ structure is a special case of a graph that imposes a restriction on how cells may be connected. So this study it compares ZZ structures to other structures, and it defines the restriction that the right edge can only connect to the left edge, or the positive edge can only connect to the negative edge of another cell within the same dimension. So essentially, you can validate a graph to verify that it complies with that restriction. So you could build a validator to know that it is valid ZZ structure within any arbitrary graph structure using whatever graph technology you want. Okay, so tools for building DZES data structures may choose to enforce it so that if there's any mutations of the graph that they always comply with that restriction and you take advantage of features specific to ZZ structures. So there are some features defined in Ted's cosmology paper which apply to ZZ structures, which make them very powerful. Okay, so I'm starting with the hypercore protocol, but I want this to be protocol agnostic. So I don't know how to get this in a state where it could be standardized. That's the project for people who can work on standardization of that. And I know there have been efforts with RDF, but if you want this to be protocol agnostics, like say an IPFS protocol can access decentralized ZZ structures, then yeah, we want it to be protocol agnostic. Okay, so yeah, So the decentralized internet is ultimately append-only logs, which are hypercores. They get replicated across peers who subscribe or seed them. Okay, there's built-in versioning. Peer discovery is by the network, the hyperswarm. So you're abstracting all the network connectivity via APIs, which is nice. So it enables, if I know the address of a hyperdrive anywhere in the world, whoever has it can connect with me. Okay, so I don't need to know the server, user, or URL. And in Ted Nelson's models in literary machines, he describes tumblers as needing to know servers, users, and not URLs, but just other aspects of how to locate something. So that hash for the hyperdrive can eliminate those levels of a tumbler structure. And sparse access, and you could have custom access methods. So there are efforts to look at indexing of hyperdrives, which can be used, leveraged, or you could design custom access methods. So we're back to the days before relational databases. Think of VSAM, where everybody had to design their own custom access methods. So it's flexibility. All right, many custom applications can be developed against the same data structures. That's important. So say you have some accessibility requirements. Maybe most people don't need them, but you could have a custom accessibility feature without having like turning on buttons. Just create a new application with the accessibility features that you need. And I want them to be able to run in an offline environment disconnected from the internet. So you could download the local copies of data and work offline. So the vision, let open source communities develop decentralized applications outside of corporate boundaries and give users the choice to take their data as they migrate to different applications. That's the tough sell. And you're not going to get funding for that. So let's keep it open source. Users can contribute their own storage and bandwidth resources to the network. So this playproject.io is a start at that, using smart contracts to enforce proper behavior of nodes. So if you have a machine you're keeping on all the time, connected to the internet, it can become infrastructure for the next generation web. So this project is called DAT. Okay. Okay, so Literary Machines is an important resource if you're going to do any work on this. It's available. Let's see. So a docuverse where all connections between documents are available and visualized in various ways. Okay, so I want to upcycle some of the conceptual structures in that book. So the semantic web has data formats already. So either ZZ structures can be built in these formats, or we could come up with something better, make it a new standard, or just a graph with a ZZ structure validator. Okay, a hyperdrive can use directories to implement tumbler addressing. So a reference on tumbler addressing is these transfinite numbers, which ultimately can be directories in a hyperdrive. And here then this byte of a document would be a .9 and a 356 link. So we can look at that in the future. Ted created the concept of enfilades, and it was expanded for Project Xanadu. I see them as additional indexing structures for hyperdrives and sharing across the network. So one important thing that Ted liked is the poomfilade, which is a permutation order of matrix, POOM filade, which was recommended to look into as useful. And I like the concept of rich links. So a link really, it always has a source and a destination, the home, and a type. And the types are user defined. So like if it's a comment on somebody's text, or an argument or a disagreement. You define the type of link you want, and ultimately you have many different rich links, more rich links than you have actual content. And links on links can be defined as well. And the Tumblr addressing is the magic, which if you extend it into the DWeb space, your links can use mathematics to do differences and to cite portions of text, and that can even enable trans copyright in the future. And edit decision lists are like a movie where you're editing and you're picking out the segments of the source movie that you want. So if everybody, authors and readers, maintain edit decision lists, they could be fulfilled via peer-to-peer connections. Trans copyright, if we have end-to-end encryption within webs of trust. That's my vision of how to do it. Others have other visions. There are some successful examples of it, like Kendra.io. Front-end applications built on the functionality demonstrated in GZZ. Yeah, so your front end would build on what we know, what's possible, and simplify certain operations. So like some things I don't like about GZZ, I want, there are some keystrokes that keep fumbling me up that they could be improved. And some concepts I'm introducing, like auto-cloning behind the scenes. So like if you try to do a connection, you can like get a pop-up that says auto-clone, yes or no, and then say yes, and it would do an auto-clone in the background. So then you stay compliant with the restriction. And hints of available connected dimensions. So in the first video, I showed you looking behind a cell and seeing available connected dimensions. That might be a good visualization, or a 3D view, or a virtual reality view, just to make it a little easier for users to navigate. Okay, multiple views of either generic graph structures or Z-structures can be built in marketplaces or open source communities. Well, that's for people to take forward. IP anonymity is external to decentralized protocols. So the nature of having a distributed hash tree is that it needs to know IP addresses of who is hosting in order to broker connections. So if you want IP anonymity, you'll have to use something like Tor or I2P, another protocol out there. Okay, so the mount feature, which I explained earlier, it allows other hyperdrives to be mounted as a subdirectory, and that's what I like about it. I could extend the Tumblr addressing space for a given user in hyperdrive and links, so it's an automatic symlink to the hyperdrive using Tumblr's in the mounted subdirectory. So if we take advantage of the mounting, then you can refer to like Bob's comments on Alice's version 2 by using Bob's tumblers. So a link would be rich because it would reference a source and a destination. So like Carol can reference Bob's comment on Alice as the source and her comment on that comment as the destination using a rich link of disagreement. And it would be Carol's home directory would be the source. So Ted draws a Tumblr square in Literary Machines showing how links are constructed. And then he goes on to links about links. So that's all in chapter 4 of Literary Machines. Okay, so we'll start with just built-in versioning, referencing by URL, because in example in Beaker Browser you can suffix plus or a minus and see versions to look at older versions given a URL of a hyperdrive to a document in a hyperdrive. Okay, now another feature I want to introduce is always transclude. So any copy of somebody else's work is always going to be a transclusion. So, so like Bob's copy of Alice's version 2 would be a transclusion from Alice. So you could always follow it back to Alice's original, but then he can add his own comments within them as new tumblers. Okay. Keep full text of earlier version. And okay, so if you're talking about EDLs, you can either do forward deltas or reverse deltas. Okay, so the example I provide is in the DZES directory. One way of structuring hyperdrives for tumblers and ZZ structures. I put a README in each directory for comments, so the comments would be ignored by any applications. Example files will be revised over time as I get comments. Hyperdrive is a way of tying all comments together in one place. You're transcluding them from their original sources using a rich link that can navigate back to the sources. Okay, so let's take a look at something here. DZES. Okay, so if you want to read and print this out, this annotated directory can follow you through all these subdirectories. The readme.txt is shown here as you go into each subdirectory. So it's explaining what the directories are in this subdirectory here. Okay. So what I would like to look at are the issues currently in this. And so I got 14 issues. So these are things that would need to sort of happen if we're going to build this thing. So here's where I keep track of things as I'm using GZZ that I want, like a warning when an operation you're about to do will break a rank or disconnect a cell, because that can frequently happen, and then you have to undo. Interference issues with certain keystroke commands are repeatedly hit wrong. Yeah, well, I could change my key mappings, but yeah, so like by hitting things like the M instead of the comma, it marks it, so maybe I'll move the M somewhere else, but that's just quality of life issues. Okay, so now let's see, linking cells across dimensions in hyperdrives. Dimensions are defined in subdirectories under the 0 directory of a user's hyperdrive. So that's a convention I established. Cells should be able to live anywhere and be referenced by their tumblers. Ranks in dimensions have JSON files that create a linked list pointing backward to the head cell, so the JSON files can include rich links to point to cells. Should each JSON file in a dimension be a rich link? Okay. So, yeah, just thinking through, where should we store things and what should be stored? What kind of rules should be established? It's open for discussion. I'm just going in one direction. Okay, so these are concepts I would like to see: auto-cloning and always transclude. So it's quality of life for users. Linking a cell to a cell that's already connected in the desired dimension should create a clone and link the clone to the desired cell. Yeah, because I find I have to create a lot of clones in GZZ. The system should never have explicit links to external content. There should always be a transclusion link. Yeah, instead of just storing URLs in text, create transclusion links. A copy of the content should be imported to the hyperdrive when that's possible. If we're talking trans-copyright, you have to put some encryption on it and figure that out. But let's assume it's a commons that we're building, so you can copy content and mark it as a transclusion. So link with the source, a URL, a book, a recording, whatever. Okay, let's see the next issue, number 4. EDL structure and implications for performance. So let's try not to precociously optimize performance, but think about it in the back of our mind. Various forms of EDLs have appeared over the years. If we define it as a list of tumblers where each tumbler locates a span of content, then it can be a JSON file with an array of tumblers. Indexing within the target file or blob would be a range of bytes. So we want to take advantage of sparse querying provided by the hypercore hyperdrive structures, and some graph querying possibly. So maybe hypercores can be used for blobs, and textual documents can be stored in hyperdrives. We need to think through the use cases of that. Okay. Yeah, what is an EDL really? And it's really, how do you compose documents in various ways? So like say each one is a paragraph. How do you move your paragraphs around, reorder them for different purposes? Okay, protocol agnostic. We want to be protocol agnostic, but what does that mean? Well, there is a browser out there called Agrigor. This is the GitHub for it, something to research, which can do IPFS and hypercore protocol. It will support multiple protocols. It keeps being maintained. So if a cell contains a decentralized URL of any supported protocol, the data can be retrieved with such a browser. Agrigor will be supporting web archives in the future, and that's a good format added to a hyperdrive so the content can be accessed when disconnected. So I find myself doing a lot of saving of web pages that I'm interested in and want to look at later, and a web archiving tool that can maintain a locally browsable copy of a website would be useful. And this would be, in my case, a transclusion of a website as of a certain date, and it could be cited and referenced appropriately. Okay. So we're thinking long-term, protocol agnostic, whatever future protocol the community agrees on. Okay, the API design. APIs can be written in JavaScript or maybe TypeScript or other languages. Run on client machines, that's the key. So instead of servers. So an API should be designed to encapsulate access to ZZ's data structures stored in hypercores or drives, so that any front-end application can call the API operations to access and manipulate these graphs or ZZ structures in the hyperdrives or whatever other protocols. So imagine an abstraction layer where you don't need to know whether you're in hypercore protocol or IPFS. You're just calling the abstraction layer to do the operations on your ZZ structure or your graph. So an interface should be defined that protocol handlers can implement to provide such API access. This needs to be well thought out before implementing the first version, because once people start using it, breaking changes cannot be made. So I occasionally take a notebook and think about things. I take some cards and think about how these might look, and you can look at these pictures and send me ideas. It's going to take a while to agree. Okay, use of encryption for confidential information. Certain material may be shared confidentially among peers and should be saved but not disclosed. Some material may only be disclosed to members of a web of trust. The sharing is an act of trust, which has the possibility of being broken by any recipient at any time, which causes some type of harm when you break your contract. The information is part of a person's personal knowledge repository and should be saved somewhere for future reference. Many encryption products exist which create a key pair and encrypt messages with a public key that can only be decrypted by the holder of the private key. An example is Keybase. So storage of encrypted files in a hyperdrive is one use case, and re-encrypting files for sharing with a web of trust is another that can be either features or add-on extensions. Encryption technologies will evolve, so periodic re-encryption is required, perhaps by a smart contract periodically reminding the owner or team to do so, or doing it automatically. The web of trust model can also be used to enforce trans-copyright, where upon receipt of a micropayment, a document is re-encrypted with the public key of the recipient, thus allowing the transcluded material to be mounted in the user's hyperdrive or equivalent technology. And the possibility of time locks. Can a smart contract keep documents with confidential information encrypted for a period of time before disclosure becomes public domain by decrypting it with the author's private key? Well, that's a tough problem. And one workaround is to store encrypted files in an external repository like Keybase and create a rich link that is a transclusion of the file in the external repository. So in a public hyperdrive, people can see that there is an encrypted file being referenced and negotiate with the owner the terms of access. That could be a website where they pay or do something. We could simulate it. Owners need to assess their threat model and choose the technology to be used for disclosure. So an example is that comes from business, mergers and acquisitions information. It's communicated through a data room technology, which allows the people evaluating it to view it for a period of time and no other access. And they can't bring their cameras into it, huh? Okay. Links to comments. Yeah, so some comments I've received are here. A nice one came from someone who's building a tool called Trail Marks, who gave me comments in Hypothesis. So I could click here. And see comments here. So here it gave me an example, and I updated it to use his link. So this is nice. Something that's one thing that's more available now. Okay, so read the comments on the article at your leisure. Operating system paths. This can be a tough issue. But depends on how you're accessing them. Long file names, path names, on Windows, there's a 260 character path name limit. Causes all kinds of problems. For an experimental system, it's okay. We're not going to use this for important data. We're just experimenting with what we could do. And then logical units of work. So say you're keeping a two-way index and you add a node, you have to update a previous node's forward pointer to the new node. That's a logical unit of work with adding the file. So unless you're keeping a log and checkpoints and ability to roll back in a failure, it gets hairy. So if you could structure your code, an exception invokes some compensation actions, but how do you know those compensation actions are going to work? So that's where people run to databases. This issue may force the design to use a graph database. It can also be a relational database, but one goal is not to require the user to depend on any specific vendor products, even like an open source, like a PGSQL. So open source databases can be used if the procedures for maintenance are automated and documented well enough for users to understand. Yes, like if I'm running a DZES node and it's easy for me to back up the database and recover by a button click. If it's a lot of automation, sure, great. But you run into the same issues as a corporation managing a database. Maybe the hyperdrive protocol. So unless using conflict-free CRDTs, replicated data types, you're going to run into this. So maybe the hyperdrive protocol can handle long paths internally in the hypercore structures it uses. If it does, then the only issue would be saving local copies of hyperdrive contents on operating systems that limit path sizes. I think it can the operating system store it all, but accessing it from the operating system is an issue. So workarounds would be needed to download files to shorter path directories and maintain the illusion that the shorter path represents the real long path in the hyperdrive. Fun stuff. Okay. Let's see. So we looked at that. Documentation of test cases. So yeah, when we're coming up with test cases for this system, you can actually use the GZZ system to document them, and I created a directory for test cases. So there's one of them out there now from episode 2, so anyone who has GZZ can download this zip file and put it on their desktop, and the instructions are here. Okay. So exports to standard semantic web formats. So say you hate DZZ and you want to get your data out. You hate DZs. Okay. It should be portable if users decide to use it in other systems. So an export process should be developed to serialize all the data structures to a graph structure, whatever is needed, GraphML, RDF, GUN, to be determined. All right, so here's the playlist link for the DZs videos on YouTube. So there are 2 so far. Go and watch them. They're fun. I'll be adding this one later. Okay, playlist of videos by Ted Nelson. So I curated my own playlist of Ted Nelson's videos to help people get the basics. So the Xanadu Basics series is in here. New Game in Town, his demos, and the history of Xanadu. And here's if you just want to see Zigzag, these are some important videos to watch to get an idea of Zigzag. Okay. And then a commentary, a recent video, what modern programmers can learn from the past, because I believe that's important. Does Ted. Because I want to see what can we preserve of Ted's work going forward. Okay. Yeah, my decentralized tech article for education has a comment. And namespaces. So something to think about. Collections of dimensions. The current method in GZZ of rotating across all dimensions is cumbersome. Dimensions should be logically grouped together into namespaces that are relevant for specific applications and even specific users. This can help avoid name collisions when the same dimension name makes sense in multiple contexts. The current workaround for this is to use multi-dotted dimension names, so like d.erangel.primeciv.mersane. So I may have some other dimensions in prime civ, but then you have another hierarchy. Mapping of dimension namespaces across users and applications would also be needed, which could be supported by transclusion links. So say someone else has a prime number dimension, and they call it MER. Well, they could transclude from mine to theirs, and then you know that MER means Mersane in their world. Okay, and that's a problem that will plague us, everybody naming things the way they want. Okay, so feel free to add issues to this GitHub if you're thinking about this. And I don't know how much time I'm going to have to actually do any of this work, but it's out there.
Making a society in which people aren't afraid kind of goes hand in hand with making a society that preserves provenance. But I think an aspect of that has to be a form of provenance that actually benefits people. The form of provenance that exists right now is one that discriminates against the individual whose provenance has been preserved. Right now, companies like Google and Facebook don't make money with traditional advertising, which romantically tries to convince you of something. Instead, they micromanage the options right in front of you. And because of the cost of choice, this becomes, for the whole population, a deterministic form of behavior modification, which has overtaken such things as electoral politics and who gets insurance, who gets credit offers, all kinds of things like that. And it becomes a social disaster. Meanwhile, of course, because of Edward Snowden, we know that provenance is being preserved on our behalf by government as well. And so the thing is, provenance must be preserved, but it must be preserved in a way that the people whose provenance is deserved are benefiting from it so that it becomes part of a social contract. And I defy you to show another way to get there other than Ted's ideas. That's the solution. You did it.